How many, if I could ask you, how many of you folks have been to one of these presentations at AXPONA before? One of my presentations, I should say. Show of hands? Oh, not that many. Well, I'm going to do something different than I've done for the last 3 presentations. And that is, normally when I go through my presentation, we only get so far in it because it's way too much knowledge to cram into an hour. So something that has become more popular as the years progress is the use of subwoofers in systems. I know most of you guys are probably stereo guys, but there's also the home theater contingent here. So normally I don't get to subwoofers in an hour. And so I decided we're going to start with subwoofers today. So I hope that's acceptable to you guys. So for anybody that has been here before and listened to the routine, you don't have to sit through it again. So how's that? The thing that I do want to cover, though, that's the same no matter whether you're talking about main speakers, satellites, or subwoofers, is some certain basic standards that we need in order to do the best job we possibly can in a room and get the best performance out of the speakers. And I do my work with something called a Meyer Sim System 3, which is an analyzer that looks at phase, frequency, and coherence in real time at 48th octave resolution. So I get a really zoomed in high resolution snapshot of what's going on in the room, and it allows me to do things very, very fast, whereas a lot of you guys are going to be trying to do some of this stuff by ear, and it's just a much longer process, but you know, you can get there. You know, if you've developed your listening skills, there's a lot you can do by just working on your system and listening and working some more on the system. So the bottom line in any job for me is listening at the end of the process anyway. The computer only gets me so far, and then I've got to listen and make sure that you know, that the speakers are performing and imaging properly, for instance. There's the fact that there's a lot of different types of speakers out on the market, and they have different types of off-axis performance, and that's going to affect how the speakers image. And so generally, I'm going to make toe-in decisions based on what I hear as opposed to what the computer is telling me. Because that's something that, you know, we just don't measure at this point. Nothing measures imaging. But really, these numbers that I'm going to give you here, I made up. You know, it's just kind of based on my experience. There's no, you know, there's wiggle room there, but it's kind of how I feel I can put my energy into a space and get results out of that space. And so I'm going to say that 70% of what I do is finding that one spot in the room where the speaker and the listener interacts with the room's boundaries to create the most linear frequency response and phase response. And that's what I really want to shoot for. I want to optimize the speaker placement and the listener placement so that then I can move on to using acoustical treatments, which I'm going to say is another 25% of what I can accomplish. And at the very end, if need be, or if somebody desires, we can always add some equalization to the system. Now, the boundaries are really, really important. And if you don't get the speakers to match up well in the room, or you don't move the speakers around and get that optimized, then the acoustical treatments aren't going to work as well. And you're going to find that you're also trying to correct for things that are more difficult than a lot of the treatments are capable of correcting for. So that's why we want to start off with something that's as flat as possible before we move on to the treatment center. And especially if in the end you're going to apply equalization, because there are some things that you just should not be equalizing for if you're going to do that. So I'm a big nut on symmetry, and the reason is that I want, even if the frequency response isn't that great, I want the speakers to match left to right, because that's how I'm going to get the best imaging. And so I really want the system to be as close from left to right as possible, so that you get a better center image, rock solid, height, depth of image, and as instruments are played across from left to right or right to left, as they go, they're in that stereo field, they don't change tonally. That's really, really important. So the concept of symmetry applies not only to the placement of the speakers, but also to the equipment and of course the relationship to the walls. So if you have, let's say, all of your gear lined up on the left or right side of the room, for instance, and it's presenting a boundary to the bass, the flow of the bass through the room along the sides of the walls, it's going to change how the frequency response looks from one side to the other. So you want to try to think about your equipment placement so that it's balanced out in the left to right field. Also, the symmetry, once again, lets me do acoustical treatments that work for both speakers. So if I've got an asymmetrical setup in a room, I may be able to correct a problem in the left speaker, but it's not going to help what's going on with the right speaker, or it may make the right speaker worse. So, you're kind of chasing your tail if you start having to put in asymmetrical room treatments into the room, because generally what ends up happening is you help one speaker, you make one speaker worse. Then you try to correct that speaker, and it makes the other speaker worse. So that's why the symmetry allows us to make good decisions on our acoustical treatments. And so what applies to your main speakers also applies to subwoofers. Because the integration of the subwoofers, when I integrate a subwoofer, I want the phase to be as close to the phase response of the main speaker all by itself as I can get it. And that way I can make the subwoofer disappear. I can integrate the subwoofer so that you don't really recognize it as being there, and it feels like all the sound is coming out of your main speaker. So let's just talk about why we would use subs. One would be you need more power in the room. That's generally not this audience, but it is in the studios for sure. One is frequency extension, and that applies to pretty much everybody, getting down to that lowest octave if possible. Another is being able to place the mains in a position that allows you to get the best imaging and vocal range response out of the speaker without having to worry so much about how the bass is behaving. And in a lot of spaces, the addition of a subwoofer lets you do that. And by adding this subwoofer, you get a similar bass response from all the speakers that are in the room. So whether it's a 5.1 system or a stereo, that's the application. So in a stereo system, my preference is to have stereo subs. I think that it typically works better, gives me more freedom to get a better phase response out of the system as a whole, and my preference. You know, some people use a mono sub, but depending on where the crossover point is, the sub position can become more apparent if you're using a mono sub as opposed to stereo subs. So when you add this subwoofer, there are several ways to put the subwoofer into the system. And so you're going to use some type of bass management to do that. And the bass management basically is, as it says, any rerouting of bass frequency from mains to a subwoofer. So it works in stereo systems, 5.1 systems, and as I've said, you're going to use that to, let's say, conform to some type of movie standard, you know, THX or Dolby or DTS. You're going to normalize the bass response within a room, or you're going to just simply improve the bass response of a stereo system. So the reason we want to do this is, once again, freedom in placement of the mains. We can kind of skew our decision-making process so we're not as worried about getting those, you know, those speakers in exactly the best place for the bass response, and we can, you know, we can concentrate on making sure the speakers image well. Because, I mean, it's possible the best bass response out of your mains is in the corners of your rooms. Not necessarily, but it could be, or up against a wall. And generally, that's not good for imaging. So you don't want that driving the placement of your speakers. So we want all speakers to exhibit the same bass response. And that's good for imaging, and it's good for presentation of the frequency response as a whole. And then, you know, in a surround system, you could always bass manage to, you know, put more power into your surround system, and also in a system where your things are getting played at high power, you save the main speakers. The woofers will fatigue less in that case. That's generally a big issue in recording studios. And probably 90% of my work is recording studios, dub stages, composers' rooms, things like that. Most of my clients are professionals. So why do people freak out about subwoofers? Well, you can get phase cancellations at the crossover point due to varied speaker distances from the woofers, especially if you're just, let's say, doing a mono woofer, one woofer in the room with a stereo system or especially 5.1 system. The arrival time differences are going to be very different from speaker to speaker, and how they interact with the subwoofer. You can get additional crossover distortion, and the worst part, phase delay, when you integrate the subwoofer to the main system. To me, that's the worst part of it. And then if in a surround scenario, if there are low frequency effects panning that's in the surrounds, of course, it has the danger, if you have, let's say, just subwoofers up front or something, it has the danger of pulling that image in the wrong way. So what I shoot for is in most cases, is to integrate the subwoofers in a linear fashion, that's balanced with relationship to the main speakers. I've got a lot of clients that are making modern records in the studios where the subwoofers are strictly power adds, and the rooms are tuned so that the subwoofers are probably sitting, I've got clients where the subwoofers are sitting 12 to 18 dB hotter than the mains. Believe that or not. So it's at that point, it's more about the air movement than anything else. It's certainly not about how to make a linear hi-fi record. So let's talk about, what it takes to get the subwoofer aligned properly. Now, my advantage is that I measure things. And to me, in this case, I have to say that phase response is equal or greater in importance to me than the frequency response is. So, so the alignment of the speaker physically in the room is very, very important so that you get that line up with the mains. Now here in this picture, what we're looking at is a window. This is a frequency only window here. And this top line here is coherence, and the line in the center is the frequency response. And in an world, it would be a fairly flat response. This would be fairly flat, and you can see that there's a fair number of cancellations here, and and then the mains roll off. So the way the subs were situated in this room was that they were vertically aligned with the speakers. So they were in the same plane as the main speakers. The subwoofer sat in the same plane as the main speakers, at the main front plane. And when the subs were added in, what we ended up getting is more extension. You can see down here, more extension in the low end. But notice how adding the sub didn't help any of these other issues in the room. And you can see you can kind of down here see this little trend down here. It's amplified once we added the subwoofer, got the extension. Well, that's because, excuse me, the problem that the main speakers are having was a front to back issue. I'm not going to take questions at this point in time. This is pink noise. Yeah, pink noise. Dual channel FFT, 48th octave resolution. So actually, this picture was taken at 24th octave resolution. This was my old system. But the fact is that the problem that the main speakers were having, which is a front-to-back cancellation, is the same problem that the subwoofers were having because they're in the exact same plane. They're in the front wall, at the front wall of the room, vertically aligned. So the subwoofer is suffering from exactly the same problem that the mains are. So we have to move the subwoofers in order to get, a proper response. So just thinking that you're going to align all your drivers physically doesn't mean that you're going to solve a problem if it's something like this. So it's something you have to watch out for. This is a different scenario where we added a subwoofer and aligned it properly. And so you can see in the top, here's the response of the speaker in the room without a subwoofer. And then down here, once we added the sub and we got proper physical alignment of the speakers, this is our response. And in a high resolution shot, this is pretty flat. This is something that that your ear can adapt to. It's a pretty good response, especially when you consider that it's just strictly a physical alignment. So here is an example of getting bass extension to the system with the proper phase alignment. And so this top window here, this is frequency response, and we've got an overlay of the system without a sub and with the addition of the sub. And then the bottom is a linear phase display. So when you this is an overlay of the sub and no sub also. But I mean, generally in an ideal world, but it never happens in the bass domain, you would have a fairly flat phase response, you know, but once again, rarely happens with subwoofers. But this, you can see this is just a wrap. It's a graphic redraw of what's going on in the phase domain. So basically this is plus or minus 180 degrees, and down here at minus 180 degrees, the trace has nowhere to go, so it just starts over here. So it's not in this case, you can see we've got bad coherence and there's a cancellation there. So there's a rack in the phase. There's a high degree of shift in the phase, and there is a cancellation that's coming in and causing this hole here. So, but the integration of the subwoofer below 90 hertz here, you can see how good the phase is tracking. And what that means is that you're not going to identify a time delay from the sub-frequencies. And that's really the secret to getting a good integration of your subwoofer. So you don't want to put a sub in if it's going to slow down the arrival of the bass frequencies, because it's going to end up kind of sounded bloated, bloomy, larger than life. I know some guys like larger than life, but in my world, I'm going for accurate, accurate as if possible. So here's an example of power addition with good phase alignment. And this was done with second order high-low pass filters on the speakers. And you can see the top trace, we really just simply duplicated the performance of the main speakers and used the sub to give more power to the system in the subdomain, which takes some of the heat off of the main speakers. So it means you'll get a longer lasting system, less fatigue on the main speakers, and you can see how well the phase when we do something like this. So this is a picture of a sub alignment where we got pretty good frequency response alignment, but we didn't get good phase response alignment. And so this is what I'm just trying to say to you, that just looking at something in the frequency domain isn't the best way to integrate a subwoofer. You really need to try to look at the time domain as well, because in this case, what's going to happen is you got a good response out of the system, a good addition there, but it's going to exhibit those bloomy, long-lasting bass notes that we'd like to try to avoid. So that, like I said, very, very, very important to have good phase alignment when you're going to integrate this subwoofer. So what are some of the things that I look for in order to do the best job I possibly can? In an ideal world, and I'm going to say about 20% of the time, I find that I can do a passive addition of a subwoofer to a system. That's where I would have a low-pass filter on the subwoofer and run the mains full range. And that's really an ideal scenario. So the subwoofer adds power and extension, but we don't have to cross over the main system. But that, like I said, that happens about probably 20% of the time in my experience. Otherwise, I generally need to have a high pass on the main system and a low pass on the subwoofer. So a real true crossover, and not just the low pass on the main system. I want to see a polarity switch on the sub, because that can help you get the alignment closer, and there's really no reason. It's not about direct forward or back movement of the speakers. It's not something that you can do with a pair of poppers. You have to do it, with the phase chart and the frequency chart. Because depending on where the subwoofer ends up in the room, you want that phase to be proper at the crossover point. And so it's, like I said, you can't do it with a polarity tester. You have to do it with something that reads phase. And the polarity switch can be helpful on the sub if you've moved the speaker, if the speaker winds up being out forward from the main speakers or back, it can come in pretty handy. If you have a variable phase control also, a knob that you can spin 0 to 180, that's really helpful. And of course, you're going to have level control on the subwoofer so you can integrate it properly. So generally, I would like to keep the subwoofer crossover point as low as possible. That helps in directionality identification, and it allows the mains to do what they're designed to do. Usually, it's a much higher quality system than what a sub is, and we expect more from our main system. And so, but this is in this particular case, I wanted to just demonstrate that that sometimes we have to do things that we don't really want to do. In this scenario, we wound up having to integrate the subwoofer at a higher crossover point. You can see right in here is the mains had a big hole and a peak here. And by adding the sub, we got a very, very linear response out of it. And our phase stays pretty good down to about, I can't read this on my screen, but I'm going to say down to about 50 hertz or so. Our phase is reasonable. So we're not slowing the system down all that much. You can see there's not a lot of racking going on here. We've simply moved the rack point down about 20 dB or 20 hertz or something like that. So we didn't slow the system down very much when we did that. So I want to talk about placement of the subwoofers a little bit. I don't really have any slides for that. I could show you a bunch of slides about moving subwoofers around the room, but it really doesn't tell you what you're going to have to do in your room in particular. Because every room is its own unique animal. So, earlier I told you about a physical alignment of the speakers in the front wall plane. And in that case, it didn't work, but there's plenty of rooms where that does work. I think that the best thing I could impart to you guys today is to take the rules of thumb that everybody's been teaching you, and that they're all over the internet, that certain things are just bad and you shouldn't ever do them, and just throw all that stuff away. And then approach your room with an open mind and do whatever it takes to get the best integration, the best placement on your speakers and the best integration of the subwoofer. So can the subwoofer go in the corner? Generally, that's not where I want to put the subwoofer, but sometimes the subwoofer performs best and integrates best in the corner. Sometimes it's in a linear, vertical array with the speakers. Sometimes it's in the middle of the room. Sometimes it's 3 feet in front of the speakers. Sometimes it's along the side of the room and 2 feet forward. Sometimes it's turned around backwards and facing the front wall, where by doing something like that, sometimes I'll see a hole in the 50 or 60 hertz region, and I can spin the subwoofer 180 degrees, bounce it off the wall, change part of the direct path length difference, and fill that hole in. It just loads that frequency. I mean, it's something you have to be careful of. You could get other undesirable responses. There's generally a lot of give and take here, where you have to, you have to look and say, well, I've solved this problem, but now I've got this other problem. What's more important to me? What's more important? So there's never a continual improvement path. You'll find that sometimes you're finding an average that works and gives you the best overall response, but like I said, something may end up suffering that you weren't, a problem would arise that you didn't have before. But like I said, you have to listen and balance that out. Which frequencies are more important to me in my listening experience? So, I've done crazy stuff. I've had speakers, subwoofers laying on their back, raised 2 feet off the floor, firing up at the ceiling, to use the ceiling bounce to fill in a hole that existed in the room that I couldn't solve any other way. So crazy stuff, but it works. And if you get a good phase alignment, you're never going to know that the speaker isn't, doesn't look like the pictures of a lot of people's rooms, let's just put it that way. So you just have to remain open, to trying anything. So that's the most important thing you can do today, I think. So let's talk a little bit about, acoustical treatments for bass. By using bass traps and bass treatments, we can get, of course, a more universal performance throughout the room for the low frequencies, which translates into a much larger sweet spot. And really, you want to be creating as large a sweet spot as you possibly can in your space. So there's different trap styles. There are tuned membrane absorbers. There are low-profile membranes. And then in the studio, we do a lot of large broadband absorption because we have a lot of space. Designing a studio, generally there's enough room you can take a couple feet in the back of the room and build some large bass traps if you want to try to eliminate that back wall reflection from getting back into the listening position. But in most of your cases, you don't have that kind of freedom, so the low profile stuff is handy. There are also the electronic tunable traps. Those require a fair amount of skill, and with measurement gear, you have to map out all the pressure points in the room generally before you can find the right place to put your electronic trap. Although the same thing applies to acoustical treatments. If you put an acoustical treatment to absorb, let's say 100 hertz, into an area of the room where there's a null, you're not going to get anything. There's not going to be any energy there to absorb. So you have to be cautious about how you place these bass traps. You can't just assume, for instance, that corners are bad things. I know that's another one of these things that are running around the internet. Oh, you got to treat your corners. Well, that's really not the case at all. Probably, I'm going to say 30% of the rooms that I go into where they have corner traps. I see a hole somewhere between 75 and 125 hertz, and the first thing I suspect is the corner trap. And sure enough, we take those things out, and that hole flattens out, and the guy put these corner traps in and shot himself in the foot, basically. He sucked out frequencies that didn't want to be sucked out of the room. And that's not to say that corner traps are bad. I'm just saying that, once again, every room needs its own set of treatments, and it's unique. And so I'm going to just show you right here where we took a tuned membrane absorber and put it in the corners, because by measurement I could find that there was a buildup of like around 75 hertz in the front corners of this guy's room. And what was happening is that energy was building up and bouncing back into the listening position out of phase, and was causing a hole that was, about 30 dB deep. And you can see that's this teal response here. And so what we did is we took some tuned membranes at 70 and started putting them into the corner. And we kept putting them into the corners until we didn't see any more improvement. So we just took a surgical approach to this thing, used as many as we needed, not too many, because we don't want to start to go in the opposite direction and create holes. And we want to try to be as surgical as possible, so we're not affecting other frequencies absorbing other frequencies around it that don't need absorbing. And you can see that when we applied these tuned membranes into the corners, not only did we correct the frequency response quite a bit, 18 dB as a matter of fact, but we also corrected the phase response. So that's the approach that I'm trying to take, and I would encourage you to go for. Surgical treatments of the problems that you've got, rather than going with something that's broadband. I'm going to wind up here with a couple of pictures. This is a low-profile RPG Modex plate. It's most efficient around 65 hertz, and it's in a home theater in California, and we had limited space, so it's a 4-inch deep bass trap, and was very effective for picking up some of the bass frequencies that were bouncing off the back wall and causing cancellations in the listening area. There's lots of, like I said, lots of different kinds of traps on the market, I can't make any specific recommendations to you guys because every room kind of has their own thing going. Like I said, some rooms you want corner traps, some rooms you don't want corner traps. Some rooms maybe you want bass traps on the back wall, or you may need some kind of trapping in the ceiling. You just have to treat each situation as unique. This is actually a trap that and a scattering device. So this is called a Harmonix K, also by RPG, but it resonates at 100 hertz. So you can use it to scatter sound. You guys call it diffusing. In this case, there's not a number theory. It doesn't follow the classic number theory of diffusion, so we call it a scattering device. But it does break up first-order reflections or reflections off of a wall and open up the reverb time of the room, but it can also absorb 100 hertz. Might be a good thing, might not be a good thing in your room. It's something that's driven generally by measurement. But overall, a pretty good device. These are drop-in ceiling panels, actually. So they can help a bit there. So that's pretty much it. I did have one request. Somebody at another table at dinner last night suggested that I, was asking me about using multiple subwoofers in a room. Basically, since you guys are primarily stereo, it's not something that I would do in a stereo room. But I'm going to show you a slide of how well it can work, especially if you're a home theater guy. This is the placement of 3 subwoofers in a room. There was one up front, and there were one on each side of the room. And you can see down here, here's the response of the speakers individually. And, this yellow one's not too bad. I mean, they all have their strong and weak points. But when we combine them all together and balance them out, manipulating, phase through delay and playing with the level, we could create a big giant sweet spot with a very, very flat LFE response here. So this was strictly an LFE channel. So that's subwoofers. So I'd like to open up the questions, and you don't have to restrict them to subwoofers, but I'd be happy to answer whatever questions you might have. Yes, sir.
Yes, for a home studio, what's your opinion about ceiling height?
Well, the higher the better. I mean, for studios, that's a great thing, So, yeah, most home studios are going to be 8 feet. You're just kind of stuck with that. And that's kind of classically, I think, could be a 70 hertz cancellation. Depends on where your mains are. If you're working with one of the things about subwoofers versus mains is, and especially in the studio where you might have near fields, the near fields generally are positioned at about, the woofer generally ends up being positioned at about 4 feet, right about in the center, between the floor and the ceiling. An Aeron chair, a typical studio chair, would put your ear height at between 48 and 50 hertz. 48 and 50 inches. So another advantage of adding a sub to correct the bass frequencies is that sub can sit on the floor, as opposed to right in the middle, of the floor to ceiling bounce. Yes, sir.
I'm unclear whether or not you favored the approach of using a low pass only or a full section crossover when integrating the sub. Because I thought at first you said it would be better to just use a low pass only, but it sounded like you reversed your opinion.
No, well, let's put it this way. I think that we need to use whatever works best. The first thing I'm going to go after is a low pass filter with no high pass on the mains. That would be my ideal to get the best performance out of the mains. Get all the beauty out of the mains that you can and just fill with the subwoofer. So that's what I'm going to shoot for. But in most cases, that's not what works best in the room.
But if your sub has a lower frequency extension than your mains, and your mains are changing phase as they enter the stop band, aren't you going to be subtracting in that area?
Oh, you mean by low passing, by high passing the mains?
You're going to have the natural mechanical high pass of the resonance of the system.
Correct. Yeah. Whether you put
Or then it'll be a different amount of phase.
Yes, whether you you let the speaker roll itself off and you get that phase shift, or you roll the speaker off mechanically, you still get some kind of phase shift. So, yeah, there's always something there. It's how skillful you can get that speaker placed to linearize that crossover point in the phase domain.
All right?
Yeah.
There are also other considerations such as the overall power handling and the available power for subs versus the tops. And I haven't heard any of those topics addressed and how you come up with what the ideal point of crossing it over.
Well, I mean, I don't have time. Sorry. You know, I mean, how much can we cover here in the time allotted? You know, I mean, this is like.
I think for a lot of people, when I say thank you for your time, but those are some questions that I felt were left unanswered.
Oh, granted, yeah. I mean, there's lots and lots to do, but the way I would want to show somebody would be to actually do a demonstration. I think it would be more proper to do a demonstration with speakers in a room, and get them to see for themselves how the phase and the crossover points work. Yeah, I mean I can't really explain it. You know, I mean, all I can say is I guess it's my job to interpret the data that I'm getting on the screen and make it as linear as possible. You know.
I found adding the high pass to the main system by reducing the excursion was generally oil when passing some sort of compromise will actually lower considerably the distortion from the main system by keeping the VL more constant by minimizing the excursion.
I agree. I agree completely. Yeah, I agree. I mean, that's true. And generally, like I said, you know, most of the time, I'm high passing the mains. The majority of the time. But if I can integrate it without a crossover, I like doing that. You know, I like doing that. And the clients kind of like that too. You know, in the world of less is more, you know, but most of the time it doesn't work. It works the way you're talking about. Yeah. Yes, sir.
The photo that you showed of the room that's under construction,
Mhm.
the building base traffic. So that room was still under construction. How did you do the analysis and determine that that kind of traffic was working?
I take speakers into a room. Once the walls, the shell goes up, I take speakers into a room and do measurements, and that's how I determine where the treatments go and what kind of treatments I'm going to need. No. Those are fixed studs. Those are the shell. That shell is fixed. That's why we're basically applying treatments to the walls of a finished room. Those studs are for depth. They're going to wrap fabric. Those are going to be fabric wrapped walls. I mean, those space traps could sit on a wall by themselves, but that's, yeah. And that's really, most of my success is because I do that sort of thing as opposed to drawing everything up on paper and using theory to say, well, we're going to need, you know, you're going to have this modal problem, or you're going to have this kind of build up with this length, path length, and design something, and then getting into the room and go, oh, that didn't really work as well as I wanted it to. You know, so generally I'm a pretty hands-on guy. Yes, sir. Yeah, I mean, I don't really know much about the lower end measurement tools, but you want to. But I can tell you this: don't use an iPhone. You know. So you know, I mean, that's pretty much. You know, there have been guys presenting AES papers, you know, Audio Engineering Society papers on iPhone performance, and it's scary. You know, it's scary. So I don't know how some of these phones are getting, and these programs on the phones are getting their base information, but it's not coming through the microphone. You know, I mean, it's how, I don't know how they're doing it, but that's not, you know, I'm just going to leave it at that. But so you would like something that, a tool that will allow you to measure phase as well as frequency. That's what I would say. Generally, the units that I would recommend that are lower scale than mine, my system's about $20,000. So there's much less money you could spend I mean, if you've already got a computer of some sort, you could probably spend a couple $1,000s on some software and a microphone and a USB, preamp. There's a program called SMART, SMAART. There's another program called SpectraFu, and those are sort of mid-range, types of products as far as pricing goes, certainly. Yes, sir.
If you're taking the assumption that a square room is probably a terrible place to start.
Yeah.
And you have some leeway in building a room. From the standpoint of a rectangle, what would be the ratios with an 8-foot ceiling that you would suggest?
Yeah, no, there's a bunch of ratios out there, and they all have their pluses and minuses. So, no, I don't have stuck with and rarely being stuck with an 8-foot ceiling, I'm stuck with other dimensions as well. So, if I'm designing something, I'm never stuck with an 8-foot ceiling. So I don't really have an answer for you on that. That stuff's all on the internet. I mean, it's basic. There's lots of programs. You can go to websites and look at room ratios, and and they show you lots of different concepts of how you can do it and how your modal distribution will be. But I will say this, though, is that I feel that while I want to maximize the modal distribution in the room, I think that the speaker boundary interference patterns are really more important. It's nice to start with good bones, but it's not the end of the world if you don't have them, because the most important thing you can do is, like I said, move the speakers around and find out where they play nice with the listening position.
You actually should find a decent setup in a square room if that's what you would be.
Square is pretty difficult. Square is pretty difficult, but better than a cube. I get, sweat breaks out on my head. Somebody says I've got a cube, so. But square is not so great, Yes, sir.
Any situations where raising the subwoofers higher or lower in the room has a positive impact in terms of the frequency response?
Yeah, because at that point, the issue is more about the floor to ceiling bounce. You're playing with that dimension if you're raising or lowering it. And in some cases, in some room heights, depending on the dimensions of the room, of course, that may be helpful. So, and I've done that, I've done that. So, yes, sir.
You're talking about tuning these traps. How wide or narrow would that be?
Well, the manufacturers that build those things, generally, they're, with the membranes, the tuning is around 1/3 of an octave, 1/3 to 1/2 an octave, generally. I think I guess it's a limitation on, the part of it's the depth that they have to work with. Also, if it's a corner trap, you'd get a broader absorption, broader band absorption if, let's say, you make the trap, let's say, 12 inches deep as opposed to 7 inches deep or something. Well, the most narrow ones are 4 inches that I know of. Oh, frequencies. Yeah, I'm going to say 3rd octave. Most of them generally right around 3rd octave. I don't think there's, if you needed to go after a 12 dB high Q peak in your room, you might be better off to do it with an electronic bass trap. Something that's that. Okay. I'm sorry. You're saying Well, you don't necessarily need a giant speaker to get down to 20 hertz. I'm sorry. Okay, no, I understand. Good. That's a great question. Yeah, why would you? And if your plan is to have a three-way system with the, okay, so he's saying, why would I buy? I'm going to just use a Focal. Yeah, because I'm a Focal Utopia dealer, so I'm going to say this: why would I buy a Grand Utopia for $200,000 when I could buy a Diablo Utopia that only goes down to 40 hertz, knowing that I'm going to add a subwoofer and cross it over anyway, and let the subwoofer handle the bass frequencies? That's a really, really valid question. You know, generally, I mean, in a lot of the cases, the subwoofers are afterthoughts. You know, people already have their speakers in a lot of these cases. But if I was going to buy a system go out and buy a system from a store, yeah, I could get a much better. I have a much better chance of getting a really linear response using a satellite, let's say a Diablo, with a subwoofer and a crossover, than I can just with a full range speaker. Because I can optimize the bass response, I can optimize the satellite response, and generally they're not the same. It depends on the room, of course, but a lot of times they're not the same thing. Plus, you can get more extension, you know, with spending less money. So that's really what everybody wants to hear, right? Yeah. Yes, sir.
You show us a lot of measurements. I'm wondering what correlation you found and your clients have found with listening results after following what the instruments measure. And related to that is what role the ear brain measurement tool has with, you know, making some of these decisions.
Yeah, that's a question that we don't have time for. You're going to have to be the last question anyway. It's 12:30, but yeah, there are things that look bad on my tools, but the brain just kind of blows over those things. Very, very high Q dips in the low frequency region that you do. Even some, convolution of the high frequency domain. The brain just integrates that sort of as artificial reverb. You know, I mean, it's just extended reverb time or something like that. So, I got into this business as a musician in '71 and became a recording engineer, spent a lot of time making records, and I've got a lot of listening experience over time. And if I give a chart to a client, a lot of times I'll get these phone calls going, what's that? You know, what's this? And it's like, well, do you hear a problem? And no, I don't necessarily hear a problem. I mean, things like high Q peaks are going to be very destructive because the way the brain works is the peak may be very high Q, but the brain has masking. It has a masking effect, and it actually it tends to make the frequencies around that peak drop down even further. It makes it, it appears to be more extreme. So high Q dips are less of a problem. Yeah, high Q dips are more forgiving. I'm over time. I'm sorry. If you have any more questions, I've got a table out in front of the marketplace, and I'll be there. I've got an appointment right now, but I'll be there after 2 o'clock today. So.